What's going on, folks? It's another video that I'm doing. This one I'm not gonna do any I&E labs tonight, simply because of the fact because I know the next one's gonna be pretty long and I just don't have it in me today. But plus I gotta do some theory stuff. But anyway, I wanted to. This is my working lab that I call it. This is my working technology lab. Essentially, all the different things that I study, I implement in this particular topology. That way I get a little bit more hands-on and I can get a little bit I feel a lot looser whenever I'm working with it because it's my own network, and if I break it I break it. So other than like my labs where I'm trying to stay by the book, by the task. So it just gives me a little bit more freedom to play around. So this is what I use this network for. But what it's comprised of, and I'll just go over the basic topology before I go into the feature that I want to configure today. So what it's comprised of is a mixture between iOS XR, iOS XE, and as well as IOU routers. The iOS XE and the XR routers make up my core and my PE routers, and all my customer routers are all IOU based devices, just to help save on processing. And I'm using Eve NG as my simulation platform. So today what I want to do is so I'm go even more into the topology. So what I already have configured here is I have VPN v4 sessions between my route reflector that I made here, this R2 router, who's the route reflector in the network here for my VPN v4 sessions. I went ahead and already enabled the MDT address groups as well. Well, some of them I did. I got to make sure. A couple of them I didn't. But that's what we're gonna be doing today is actually multicast distribution trees. But what's already configured there is the VPN v4 and all the VRFs that you see, red, green, and yellow. That's already configured. This iNet router is actually an internet router that I was simulating um, internet routes, so that way. Because all these routes, so that connection to the cloud is actually be able to get to the internet, and so this R23, I'm simulating an internet connection for my different options for doing internet service, providing internet services within L3 VPNs. So that's the topology overall. So you guys can get an idea of what's going on here. And like I said, today I'm going to do multicast distribution trees, and we're just going to focus on the red VRF today. I went ahead and did this. Prerequisites is that your core has to already be pre-configured with some type of multicast, whether it be an anycast or a source-specific multicast. Um, in this particular case, what I'm going to do is I'm going to convert everything. Yeah, well, I'm going to do it with the auto with the BSR RP election that I got going here. So I'll leave that as is. So, and then what's going to end up happening is that I'm just going to do a very basic MDT configuration, which is MDT default groups, and then in another video I'll probably end up doing the one converting my core to source specific multicast, and then enabling MDT data groups as well to help make my multicast distribution a little bit more efficient. So on a very basic standpoint, we'll just go ahead and get it enabled on the PE routers. The core is already done. The RP in this particular network is going to be R2. So he's the RP for the service provider core network. And then for red, I'm going to make the RP router 3, which that's already configured. So R6 and R5 have already been pre-configured and tested with R19, just to make sure that multicast is actually working through the rest of the network. What we're going to have to do is R9, R10, R13, and R11 as well to go ahead and get the tree formed that way as well. So we'll go ahead and get started here. First things first, what we're going to need to do is we'll start with router, and I can't remember how I did this. Let me make sure that, because one of them is actually in a global pairing from router 17's perspective. So let's do this here. The interface brief. So I don't think I did it yet. 10.17 show IP route. So he can get the 3, and then he has 19's address. And that's going out 10.17.1. Ethernet 01. Okay, so he's going up there. Let's see what R6 is doing. Show IP route. So IP. And he's going out to Ethernet 01. So they're both going to router 10. So we're just going to do router 10 in this instance. Router 9 is serving as my public router. He's actually providing internet service over that connection. So um, we're going to go ahead and keep it basic here for router 10. So on router 10, let's go ahead. Let's get a few things. So we're going to need to enable the multicast. Let's go ahead and close some of these sessions out just so I don't have it so cluttered. We're just going to need R10 for now. So R10, just verifying that it has its PIM neighborships. Show IP PIM neighbors. Should have one to R8, which it does. And then show IP PIM RP. And we've got the BSR, learned RP mapping. So that's good to go. So router 2 is our rendezvous point. So what we need to do is we're going to need to enable it, enable multicast for the VRF red. So IP multicast. So yeah, IP multicast dash routing VRF red distributed. It's good to know. And then we need to go ahead and add both of our interfaces 4 and 5 and add PIM sparse mode. So interface range gig 4 through 5 IP pin. We're just going to do sparse mode. So that should be good there. And then I think we also need to advertise. So BGP IPv4 MDT neighbor. MTT all neighbors. I don't think I have the address family activated. So run section. So run section router BGP, and I don't, so I'm gonna need to take this and change this around here. Okay, IPv4 MDT, so let's go underneath our BGP process, router BGP 100, and then we're gonna activate that. I already configured it on the route reflector for all the neighbors, so this should actually apply already. And then if I should be able to do neighbors, good. So BGP all summary, and you're seeing we're learning 2 prefixes. And let's go ahead and see what these updates look like. So what's going to end up happening is that you're going to add another field in the AFI-SAFI position, and within the packet, what's going to be there is going to be the MDT group address as well as the originator of the prefix. And this MDT group address is already configured under the VRF. Actually, I don't think I configured it yet. Section VRF def, and it is not. So I need to go to VRF red. Router BGP, oh no. VRF definition, just family IPv4 MDT default, and that address that I used was 239.1.1.1. Good, and we should have 2 tunnels pop up. Well, it's going to be one tunnel. It's a multi-point GRE tunnel that we're going to form neighbors with our other PE routers that are participating in this MDT group, which is going to be router 5 and router 6. So from the PE perspective, that's good to go. So let's go ahead and log into the CE router, which is router 17 here. And ideally, what I should be able to do, I want to make sure that I still have my join on my router 3. So loopback 3, interface ETH00. Don't have a join there. Let's see this. IP IGMP join group 255.3.3.3. Alright. Oh, 225. It's definitely not an IP address. That's good. So on router 17, what we're going to do is enable multicast globally. IP multicast dash routing. And then under the interface on router 17, we're going to go ahead and enable PIM, IP PIM sparse mode. IP, we should have a neighbor come up, IP PIM neighbor. So IP PIM RP, and we should possibly, let's see if it works. So we should ping that address that I assigned to, that I joined group that I did for router 3, which is 255.333 or 225.333. So let's go ahead and ping 225.333, and I know already that I just talked to the, because I have BSR running, so I know that that came up. So I was able to register with the RP. If I should be able to ping router three's that multicast group that router 3 is joined, and then I should see packets come back from router 3, which is the 10.3.6.1 interface. So that tells me that we're actually flowing multicast through the actual MPLS core, and traffic is bidirectional. I should be able to check also by the do show IPM route, and I can see there we're good to go. 10, 17, 2, 3. This is for the incoming. So because the source here is right on the local on the local device, which is router 17, we're getting an IP RPF neighbor 0000. But as you can see, the RP for the 255.333 group is 10.0.0.3, and from there, our RPF neighbor, which is router 10, is where we're building our share tree, and then the source tree is built coming down back, which in our case we were the source, coming back to us. If we go to router 3, we should do a show IP route, and looking at router 3, so those are ping, the initial ping, yeah, because the source tree was built from router 17 up to me, and then on the share tree, with since we're the root of the tree here, we're actually, oh, you know what? I kind of did this in a backwards manner. Let's go ahead and, you know, I should go ahead and take this off. And so interface Ethernet 01 IP IGMP interface Ethernet 01 IGMP join group 225 dot 17. So router 3, we should be able to see the shared tree show up here for that 17, 17, 17, as we see here. So he's the root of the share tree. Now if I ping 225.17, 17, 361 is where the incoming packets are coming from the source. And if we go ahead and trace this down, so this is gonna look, so what's actually happening in the background too as it's going through the MPLS core. If I go to router 3 is gonna know, or router 6 is gonna know about this group within the VRF table, but he won't actually be forwarding through the MPLS core based off of that address. That's gonna be based off of that MDT default address. So if I do a show IP mroute VRF red, I should see that, there it is, the 361 outgoing to tunnel 1, right? So the source being router 3, and I'm pushing traffic downstream to tunnel 1. Tunnel 1 is actually show IP PIM VRF red neighbor. Tunnel 1 should be that MGRE tunnel that was formed within the actual, VRF, the PIM adjacency. So based off of that, if I go and I look how the forwarding is done in the global table, show IPM route, you notice that tunnel 1 isn't going to be showing up on any of the in the interfaces. What you're going to see is the MVRF VRF. And so, based off of the forwarding address, which is the 239.1.1.1, which is the MDT default address that we assigned, that is what the address is going to be forwarding based off of. So, as it goes through the core, it's actually using the default address, but from end to end, from the customer's perspective, he just sees his regular RP giving him the shortest path, which is just going to be the exit interface going into the PE from the CE router's perspective. Um, so that's pretty much that. If you guys have any other questions, let me know. This is just a quick one I wanted to do, show you guys MDT trees. It's non-official. I'll eventually get to that in my INE lab guide. Um, and when I do, I'll go into a lot more detail as far as the theory is concerned and how it all works. But I'll do another video. Well, actually, what I'm going to do now is probably just going to transfer my lab into a source-specific multicast network, and then start running it with the MDT data groups because oh I'll go into that in my lab as well. But there's going to be some key benefits in running the source-specific multicast within the core, as in regards to the MDT data groups. So in the next video, I'll go ahead and explain all that, guys. So thanks for tuning in on this quick one, and I appreciate it. Later.